Thank you. Thank you, everybody. Thank you for the invitation to this amazing conference. The Netherlands is a very special place for myself because it happens that I spent here my Erasmus year at university, which has been one of the most amazing time of my life, so I'm always happy to come back here in the Netherlands. This talk, well, my name is Marco Consolaro. I am an independent freelancer. I learned to code when I was 9 years old, and now I live and work in London since more than a decade. I'm recently also a technical author, since in December our book has been released. These are mostly technical books, a technical journey to mastering software design. But in this book, we mostly talk about doing the things right, but we end on doing the right thing, right? And so there will be a few concepts that I will show you later that you will find also in the book. This talk is mostly a journey into my mind. I had a lot of different experiences. I read a lot, and I try, in my mind, I always think in trying to connect the dots. And in this talk, I will share with you a few considerations, which I think they make a lot of sense in my mind. So I share with you, hoping that you find it interesting and it might resonate with you as well. So, in my life, I've been through many projects. I've seen many teams. I've seen a lot of teams succeeding. But I have seen also many, many teams failing. And I've seen agile team failing. I've seen team applying DDD failing. And I've seen also team cowboy teams without strategy succeeding. And I've seen also waterfall team succeeding. And so there is always a question in my mind that going on, it's why, right? The one among you that know Lean and the Toyota production system might know the 5 whys technique to go to the root cause of the problem. So I have inside myself this question all the time. So I was thinking, what is the real core root cause about success and failure? Because it cannot be only the methodologies. Of course, that helps, but it's not enough. So I was thinking, what do we do, right, to succeed or to fail? Well, think about that. The idea is that we always do decisions. We make decisions all the time. And success and failure is the outcome of these decisions. If we take enough decisions that steer us towards success, we succeed eventually. Instead, if we take enough decisions that steer away from success, we don't. It's a little bit like a decision tree. If we put these decisions in a timeline, we have like a tree. So the more decision we take, right, if we consider the node, our decisions, and the edges, the options that come as an outcome of this decision, we can see a tree. And the more we take decisions that go toward the goal, the more chances we go to reach it. Instead, if we take more decisions that steer us away from the goal, don't, right? But the problem is that when we take decisions most of the time, we don't really see all the tree. We see it more or less like this. We have a decision to take, and we have options, but we don't know straight away the consequences of our decision. For instance, let's suppose we have to choose a cloud service. We could choose Amazon, we could choose the Google Cloud, We can choose Azure. But we don't know what is going to be the next decision we have to take. And choosing one or the other will change the subtree of decisions. We will go through all different set of decisions. We can reach the goal, any path we take, but the path is going to be different, right? And the thing is that we discover the next options only after we have made the action toward the decision. We cannot know it before. We discover it along the way until we eventually reach the goal, right? This is why Claude Shannon said, we know the past, but we cannot control it. We control the future, but we cannot know it, right? So the question is, how do we take this decision? I was thinking about this, right? And the first answer is like, well, we are human beings, right? We are gifted with an amazing, big, rational brain. That's how we take decisions. We take decisions rationally using our brain, right? But the thing is, are we completely rational? Well, while I was puzzling myself with this kind of question, I realized we are not. And so you ask, why? And it was during this time that I came across this interesting concept of bounded rationality. This is a concept that was defined by Herbert Simon, an economist, right? And it's interesting because obviously the economists put it in a field where they exploit this concept basically to sell us more stuff. But the interesting thing is that if we understand this concept, we can turn it around and use it at our advantage. So what does the bounded rationality definition say? Well, bounded rationality says that humans make quite reasonable decisions, but they are limited by the time available to make them, by the relevant information they have, and by the cognitive limitation of their mind. Well, the time is it's evident, right? When we have time pressure, it makes everything more difficult. Relevant information, well, that's obvious. If we don't have enough information, we cannot take reasonable decision. And then we have cognitive limitation. So if we accept this definition and we trust it, and then we might find a way to improve the way we take decisions, right? We can understand cognitive limitations and use them at our advantage. And then we can optimize the systemic information flow. We cannot do much about time. Time is time, right? But on these two things, we can actually work and actually try to expand the boundaries of our rationality. So let's go through this a little bit more in detail, and let's begin to understand the fact that our brain is not as rational as we might think. There's plenty of examples. This is my son, by the way. It's, there are plenty of examples about it. I choose a few that I think are interesting. The first one is an experiment they have made in liquor stores. They took a few liquor stores in France and in Germany, and they set up French wine and German wine. They took different kind of wine with different popularity, so that the experiment could come out with some strange results. And they tried to do this experiment. They wanted to see if they were able to influence the customer choice without they realize it. And so in the first week, in all these stores, they began to play in the background strong French national songs. Guess what? In that week, French wine outsold German wine. You say, well, French wine are popular, so that's expectable. So what happened in the next week when they play strong German songs in the shops? Well, even in France, German wine outsold French wine. And this has been why they started to regulate occult advertisement. There's another nice example that explains that our mind works in a very strange way. And this story happened actually here near Amsterdam. In the early 70s, so just a little bit before I was born, there was the oil embargo, for the oldest of you might remember. And they start to really pay attention on the energetic consumption. And they found something really, really weird here near Amsterdam, because there was a neighborhood where they just built it brand new with old houses, all the same, completely, exactly the same. And they find a strange pattern in the energy consumption in this neighborhood. They found that they could divide these houses in two separate groups of energy consumption, where one was consuming 33% less energy than the other. It didn't make sense because they were the same. The houses were exactly the same. So they sent somebody there to do a better study, understand where the difference was. And they found there was just only one difference. This is a electric meter, right? It's the old one, the oldest of you I have seen this before. It has a wheel that spins, and the more the consumption, the faster the wheel spins, and it keeps spinning. The difference was where these meters were located. One group of the houses has the meter located behind the staircase, so no one ever sees it. The group that consumes less has this meter set up in the entrance door, so the people could see it spinning every time they go inside and outside the house. That meant 33% energy saving. So let's do another experiment. Now let's do it here. This is a funny experiment. So let's do it quickly. It works like this. I will show you some handwriting in the screen for short amount of time. And you need to try to read it, right? Okay, so are you ready? This one? What did you read? 12, 13, 14? Yeah. Okay, let's try the next one. What did you read? ABC, anyone? Okay, so the thing is, for who read ABC, that this symbol was the same in both the slides. And the thing is that our unconscious mind works like a compiler in our brain. What happens is that our unconscious mind pick up the concept and program the information for our brain based on the context. And our conscious mind pick it up. And all these processes happen in real time without we really realize it. We have this brain that works very, very fast before our consciousness. And actually, also in our brain, context matter. It's plenty of examples of how our brain distorts and deceives, as Cordelia Fine says in this old book, A Mind of Its Own, which was the book that started my journey into this peculiarity of our brain. So this is about proving that our brain doesn't really work in the way we expect. So let's have a look a little bit deeper about how our rationality works. Our rationality essentially works in two modes. One is deductive rationality, which is very much how we play tic-tac-toe. You know, you've seen this game, right? Tic-tac-toe is a game that doesn't have too many options, so our brain can all the time work out the complete tree of decision I showed you before. And you are always in a position to find the best move. In effect, two normal opponents always draw in this game. This game, the one that wins this game is not the most intelligent, it's the less bored, right? Or the one that can pay more attention. The other way that our mind works is more related how we play chess. How many of you can play chess? Few. How many of you have done chess tournament and are semi-professional chess player? No one? Okay. However, I will try to explain how chess works. Let's start with the deductive rationality. Deductive rationality is the perfect, logical, deductive way we can take decisions. And it is unbeatable, right? It's perfect. If and only if we have all well-defined information to identify the best solution. And capacity for processing that information effectively in the time we have. So it works, but with conditions that are very, very difficult for our brain. As in the talk before, we learn our brain starts to struggle when we have more than 3 variables, right? So it's not very good in this. It's decently good, but computers are unbeatable on this. The deductive rationality is the space of machines. We can't really compare. Inductive rationality works a little bit differently. As humans, we are only moderately good with the deductive logic, but we are amazing at seeing and recognizing patterns. When we cannot process all the information, or we lack some of the information, as we have seen before, our mind creates a simplified model of the reality to fill those gaps, and so allows us to use deductive rationality into this simplified model. It works a little bit like this. We have an overwhelming amount of information, and inside our mind, more or less consciously, we take this information and create a simplified model. How? Well, there are many ways. Well, when we play chess, in the beginning, we play random, right? We don't have a strategy. You know, when you start to learn to play, you play random. Then you begin to create an experience because you play with your opponent, and then you begin to learn patterns. You begin to put together heuristics in your mind. And then, I remember when I learned to play chess. I learned when I was a kid, but then growing up, I loved to play chess. And I found a friend of mine that I realized he was a regional champion of chess. I was like, I want to play with you. It was amazing. He beat me all the time. I was able to draw one time with him. And the first time I played with him, he told me, You are skilled to play this game, but you absolutely have no strategy. Have you ever read a book about chess? I'm like, no. And so he gave me a book about chess. And in that book, I started to realize that there is a whole set of principles for playing chess. There are different kind of advantages, different kind of strategies, and it's only step one. The same guy told me at a certain point I stopped playing chess because to become really, really competitive, I had to memorize famous chess match of player of the past in order to quickly realize and internalize the situation where I was to move fast enough. Right? So to build that simplified model, we can use a lot of things. But the good simplified model is the one that is more close to the reality. And then when we have that model, what happens? We use deductive rationality on that model and take action. And this is just half of the way that the rationality works. Because after we take action, what happens? The opponent moves. And so we have a feedback about what we have done. Now, the feedback can be positive, like we see that the opponent is defending himself. So that is confirming that our simplified model is good, and we carry on with our strategy. Or the opponent might make a move that makes us difficult, right? And then we are forced to re-elaborate this model, considering the feedback, and then rebuild a different model to reapply the deductive rationality on top later. So, how does this work when we are not just playing chess by ourselves, but we are in a team that need to take decisions as a team? So basically, way more harder than playing chess, right? So, well, it works actually in a very similar way. The problem is that in a socio-technical complex system, as where we usually work, we have interactive people. That is the complex part. It's this continuous exchanging of communication and information that create the complexity. And if we have a team of 3 people, we have 3 fully duplex communication lines. But what happens if we add more people? Well, now we have 6. And if we add another one, we need to add now other 4 lines. If we add another one, we have to add 5 lines. As team grows linearly, the amount of information channels grow exponentially, and our rationality quickly breaks down. We can't rationally take care of all this information. This is called entropy. Entropy, as the degree of disorder of a system, tends naturally to maximize itself. The concept of entropy is very close to the concept of mass, to understand it. If we don't sort it out, mass tends to grow. That is evident, right, in our everyday life. That's entropy. And so, this complexity breaks down our ability to cope. Beyond a certain level, we can't cope. And then there is another factor that makes it even more difficult. Because when we are in an environment where we cannot expect rational decision from other agents in the system, we can't take well-defined assumption anymore. And we have to continuously create fake assumptions in order to fill the gaps in our tree. And it works in the same way, the way we take decisions in a group. The problem is that we create a shared model of the reality as a team. And it is very difficult, because to create a shared model, we need to have a shared knowledge. We need, as a team, to have a shared understanding. We need to share the experience. We need to share the wisdom and the practices and the habits. And if you are able to share these as a team, we are able to create a shared model where we can use deductive rationality. These shared things can be called collective mindset. Somebody call it culture. But I think collective mindset is much appropriate. And still, we can use deductive rationality on that model. The problem is if you have seen teams that aren't able to take decisions quickly because they are always arguing. The fact is not that they are not able to deduct things. The problem is that they argue because they cannot agree on a shared model of the reality to take those decisions. And then also here, the important thing is to create feedback loop and embed these feedback loops in practice habits and make them become collective mindset as well. And this, as a team, cannot happen if we don't actually do it in purpose. It's not like chess that you play with an opponent, and obviously, if you don't care to the move of your opponent, you are gonna die. As a team, you can carry on as long as you want without feedback, right? Until something fails. But if we embed the feedback loop in our mindset, and then we can actually research for it in order to help ourselves to build better shared models. And fortunately, we have many feedback loops in our agile practices. We have many feedback loops. Pair programming, for example. Pair programming is a feedback loop technique in order to add feedback on the code we are writing in matter of seconds. Unit tests are feedback about our features with a matter of minutes. Acceptance tests are feedback about the business correctness of our functions, right? And all these things are feedback loops that should help us to do better decisions. In effect, the first law of system survival from the Systems Bible of John Gall, I'm sure that some system thinker here knows it, says that a system that ignores feedback has already begun the process of terminal instability. Think about playing chess without caring the move of your opponent, right? And just calling feedback doesn't mean that it has actually fed back. It hasn't fed back until the system changed course. Obviously, it's not just about having that information, it's act upon that information when it is the case. And then the collective mindset, right? I'm sure you have seen this already. And Bob Marshall goes as far as saying that it is the collective mindset of an organization that determines its overall effectiveness, productivity, and degree of success. And the collective mindset are the beliefs, assumptions, and behavior that the organization or a team as a whole holds in common about work. It's absolutely crucial because as the system is more than the sum of the parts, it actually expresses a consciousness of its own. And our team is a system. So if we have a strong collective mindset, we are in a great position to take good decisions as a team. If it is weak, we will be struggling. So let's see how I think we can work to expand these boundaries. So, feedback, data, and experiments. I have seen an amazing talk yesterday from Natalie Rames talking about experiments and a culture of experimentation. This is exactly the point. Embracing a culture of experimentation, data-driven decision based on fast feedback loops. That's what reduces drastically incorrect assumptions and bias. We can understand that our way to take decision is not perfect, so we can experiment and research to find more data to back up the decision. We can do it deliberately, right? And this process is crucial to have our shared model always stuck close to reality. And to achieve that, what is essential is having an environment safe to fail. In an organization that disapproves of mistakes, the best strategies for anyone that seeks job security is to do nothing. Right? Somebody mentioned Akov in the talk of before. I am mentioning him a lot. Right? So it's very important that we are not, that the organization, the teams are not considering mistakes something bad. Actually, they are something really good to learn. In effect, one of the frameworks I like the most about enabling experimentation is the anti-fragile, it's the popcorn flow, which is an anti-fragile experimentation philosophy. It's called popcorn because it's the acronym of the 7 steps of every single experiment. It is a visualization technique about keeping track of experiments and keeping also the history and share the history of what we have learned with the experiments. And it's based on a few principles. If change is hard, make it continuous. It's not only what you do, but also what you learn by doing it that matters. Everybody is entitled to their own opinion, but the shared opinion is a fact, right? Collective mindset. When everybody in this team shares the same feeling, it means that that feeling is true. In that team is a collective mindset, is into the collective mindset of the team. It's not fail fast, fail often, as Eric Rice says in his Lean Startup book. It's learn fast, learn often. And then there is the anti-fragile principle, small bet, big win, right? We should try to keep the cost of our experiment small so that we can do many of it until we might find the one that gives us a great insight into something and change and give us back way more value than all the cost of the experiment we have done. As my friend Claudio said, inertia is your enemy. Then we can use bias at our advantage. We already do a lot about that. All our boards, the Kanban boards, the KPIs, build monitor, they are exploiting the same bias of the electric meter we have seen before. We visualize the work in progress so that the team focus on that, which is the most important thing. Unconsciously, that helps a lot to keep the focus. Obviously, it helps if the board is simple and it's easy to visualize the most important thing. If it is a mess, it defies its purpose. And I really like to mention this sentence from Anderson, from this amazing book, Kanban. A team with just a spread of talent can produce world-class results with the right process, good discipline, and leadership. So with a great collective mindset. So to have a collective mindset, we should share as a team, but also as an organization, a set of principles and values, simple enough to be widely understood, and strong enough for working out decisions, limiting their subjectivity. That is fundamental, especially in technical teams, right? I've seen many teams fighting among the most stupid arguments. And it would be much better to save that time to create experiments and gather the data that can give us a better way to make judgment. This is from our book. Our rationality might be bounded, but principles and ideas will always be there to guide our way. But that is not enough, because if you might have principle, you might say you have principle, but you need to live up to it. If the team don't live up to it, even principles are not that impactful. We are human beings, after all, with feelings, emotions, and an unconscious that affect us the way which affect the way we think more than what we really understand. Adam Thornhill, yesterday in his talk, put understand consciousness at the limit of impossible. Imagine the unconsciousness, right? So the human factor is a very important point. As far as we have come to the conclusion that the difficulties of a technical nature are more often than not just hiding problem of the social nature. When we see a continuous technical problem in STEAM, then you go to investigate, and then you realize that there is a clash of personalities, that it is way deeper than just merely technical aspects. It's the human, it's the social part of the socio-technical system, the really hard one, not the technical. And that boils down to motivation and trust. Yesterday, in the keynote, Eric said that one of the great things of the DDD movement is happiness, right? And when teams are made by happy people, it's when they do the best things. But happiness is relative. And what I have noticed is that happy teams are made by motivated people. When you see motivated people, they are happy to go there and do their job. So motivation is essential. And so build projects around motivated individuals. Give them the environment and support they need, and trust them to get the job done. Do you know what is this? This is the fifth Agile principle. This is my favorite principle, almost never seen in reality. So, motivation. The best book I've seen about motivation is Drive of Daniel Pink. And what does he say? Well, motivation, he says, comes from three main things. One is purpose, right? The fact that we do something that goes beyond ourselves and have an impact also for others. So we should share the goals of the company, right? If we are vegetarian and build a system for butchers, we are obviously not very happy. Huh? Yeah. Another one is mastery. So having an environment where it's safe to make mistakes so we can learn. Having a continuous improvement mindset where people are encouraged to learn new things and to be on top of their game. And the last one is autonomy, so self-organization. Many say that self-organization is hard. But the best architectural requirement and design emerge from self-organizing team. 11th Agile principle, almost never seen applied in real life. And I think it's very interesting to see how nature behave in this situation. Self-organization is very popular in nature. So let's see an example in nature. Let's see what happens in a flock of birds. What do you think? They have a principal bird that tell them how to shape themselves, or a bird manager that tell them split now? No, they self-organize. And actually, it's not, they study how they do that. It's not very complicated. This is just 3 rules. Rule number 1 is stay close but don't bump into other birds. Rule number 2 is fly as fast as birds around me. And rule number 3 is move toward the center of the group. That's it. The rules are very simple, right? And it's like the principle. We should have simple principles, but easily applicable, right? So, if a flock of birds is able to self-organize, what do you think? Can a development team do it? I think so. Here I close, right? The effectiveness of authority decreases as the educational level of subordinates increase. When the educational level of subordinates is higher than that of their bosses, it becomes negative. That's because, obviously, the subordinates is able to find a way to don't do what the boss wants anyway. The thing is, I find this situation over and over, and I believe that only self-organization will be able to get over this problem. And self-organization is made through leadership and through trust over control. So to be able to self-organize, we need to have our principles and some leadership, but we need also something more deep than that. We need also great team play. I believe that at the basic of everything, it's the maturity of the people that we have in the team. And one of the best books and ideas about team play come from Patrick Lencioni. Let's read this lovely quote. It says, when team members trust each other and know that everyone is capable of admitting when they are wrong, then conflicts become nothing more than the pursuit of truth or the best possible answer. I think this is the key. And he has also a model. He proposed a model of the perfect team player, the ideal team player. So how is the ideal team player for Patrick Lencioni? Well, it's smart, but emotionally smart, right? People that understand that their behavior have consequences also for the other members of the team. Hungry, which is not our hunger of lunchtime, but is hungry about doing things well and is willing to go over if it's required. It's the wish to do a good job. And then is humble. Humility, it is not thinking less of yourself, but it is thinking of yourself less. The great team player is able to put his own goal after the goal of the team. That is the key of the humble team player. And I believe this is the real cornerstone where we can build upon with all other principles to expand the boundaries of our rationality. I close. I finally want to close with a message. We are, at the end of the day, not just only member of our team or member of our organization and our company. We are all part of the community of IT professionals. And if we are here, it's because we are all focused on improving the way that we build software, on improving the way we work together, on finding new way to move on and work better together. So, our higher purpose should be share our knowledge. Our duty for improving the world should be sharing what we know, should be sharing our ideas, should be not be afraid to expose your thinking, write blogs, and share what you know. If you think about it, what we do in our job comes from the knowledge of the people of the past that was brave enough to share their ideas. Think about the Turing machine, for example. When Turing wrote it, he was 24 years old. He was still at uni. He didn't have the idea. He didn't think that that would become the cornerstone of modern computers. It was just his ideas in the beginning. And then the idea started to resonate with other people until that idea became the model for the computer of nowadays. So share your knowledge, share your ideas. Thank you.
We still have time for questions. Does anybody have a question for Marco? Then I'll come up with the mic. Yeah.
Thank you. I have one question. You just talked about the best team player.
Yes.
How this guy could resolve the conflicts between the team members?
Well, it's not this guy. I think that everybody should be an ideal team player. I think who is not an ideal team player has not the maturity to be in a top performing team. I think there is some maturity to gain in order to be effective in a team. It's not impossible. You know, people can mature. There is a model of knowledge that show how our confidence goes up when we are stupid, and then we realize that we are stupid, and then it goes absolutely down. And then we start really learning things, and then the confidence goes up as far as we learn, and we have the feedback from the world that actually we are learning. So it's a journey of learning, and I think we need to have people that are after that shock of stupidity in the team in order to help them to get their knowledge. It's all about humbleness. If you are humble enough, you will be able to grow your knowledge all the time in the right team.
Any more questions?
Hey, thanks again for the talk. A question: how is there a set of questions that you have found that can help recruiting team members that are efficient?
Absolutely. I suggest you to read that book of Patrick Lencioni. He has a full chapter about what he asks in the interviews. It's mind-blowing. That book is absolutely fantastic.
Thank you. Hi. Earlier you said if everyone shares the same view, then it effectively becomes fact. Did you mean to say that?
Sorry, can you repeat?
Sure. Earlier you said if everyone shares the same view, then it becomes fact. Did you mean to say that? Or did I misinterpret what you said?
If what I mean is that if we are in a team and everybody has the same feeling about something, that is a fact inside that team. It's part of the collective mindset in that team. So it's time to take that feeling and prove it, right? If there are disagreement, it's not everybody is feeling the same. So it's not collective, it's not shared. When everybody feels it, inside that team, it's a fact. So it's time to consider it as a thing that should be in that model.
So in my mind, I would have considered it to be a fact when it's proven, So until the point that it is proven, it's not really a fact. And so I might
absolutely,
be
but
pedantic.
that was in the context of the popcorn flow. So basically, what means that is a fact? It is a subject for experiment, right? It's something to put in the board and start to prove it.
Yeah, and just to add, I would just be hesitant to say it that way because I know that people can take things very literally. So when they take that and say, well, we all feel the same way, therefore it's a fact.
Absolutely. I have to apologize for the delivery because I was sick with fever until 3 days ago. So I finished the presentation. I stayed yesterday night until 2 trying it in my room, but I perfectly understand it could not be perfect.
Okay.
You also talked about teams being effective, having the same values and principles, but obviously when the team has just come together, that's not necessarily the case. Do you have some tips on accelerating that process?
Absolutely. Great leadership. With great leadership, you have people that are actually focused about this, that they own, they master this principle, and their main goal is to share them with the team. The more they are able to share their knowledge and their principle in that context, the better the leader they are.
We have time for a couple more.
Hello, thanks for the talk. When you were talking about the shared model and how to improve it through fast feedback loop, how fast is a fast feedback loop? Because this is relative to the problem or the solution.
That's a very good question. The fastest, the merrier, right? The problem is that we are constrained with the reality. So it really depends on the context. For example, the book of A Mind of Its Own. When I bought it actually at a conference. I was listening to this girl. She was in the team, in the Amazon team, when they made the first checkout, right, when it was still a startup. And she was explaining all the experiments they have done to reach the best checkout experience. And it was really funny because they made a sequence of A/B testing. And she was explaining how they were fighting to make the experiments about that. She was explaining all the different bias. And at the end of the day, the best solution came from the hypothesis that everybody was not considering even to experiment. So how fast is fast? If you have a checkout experience, you should do A/B testing in the real life. And the more customer you have, the faster you can act, right? If you are doing something that requires more time, you are forced to have a longer feedback loop. That's why I love pair programming, because that is an immediate feedback. When you do something that your pair don't understand, you have to explain it to him. So you are clarifying it also to yourself. So the quickest, the merrier.
Give it up one more time for Marco.
Thank you.